Hey everyone, welcome back. In this lesson, we're going to start talking about weather and climate and the difference between them, because this will be helpful for you as you're finishing up your climate projects this week. So I intentionally didn't put any videos out last week, and the reason for that is that I wanted you guys to have time to focus on your climate projects, and it seems to have worked because a couple of you are done or almost done at this point. And of course, as we talked during our class on Tuesday, let's see, today is, okay, so Tuesday was the 27th. Yes. What that means is that your presentations will be due 1 or 2 weeks from the 27th, depending on who you are. For most of you, your presentations are due on the 11th of May. And for a couple of you, you know who you are, your presentations are due on May 4th. If you're not sure about which date is yours, send me an email and I can clear that up for you. But anyway, so while you guys finish up your climate projects, I thought this might be a useful lesson to record, just to give you a little bit more background on what exactly it is you're looking at in your climate project. So this one is called Weather, Climate, and Seasons. In actuality, we're not really going to be talking about seasons all that much in this lesson. And thankfully, my PowerPoint is updated, so now I have this laser pointer, which hopefully you are able to see in this recording. If not, then, well, I guess we'll find that out when this lesson is done. But yeah, hopefully I won't have to draw as much on the slides to indicate what exactly I'm talking about, because now I can use this laser pointer to do that for me. So anyway, let's jump right into it. We'll talk mostly about weather and climate in this lesson, and then we'll see at the end of this lesson why seasons kind of deserves its own lesson, just that topic. So, what is weather? This is where we'll start. And this is something that we interact with all the time. Most people that have cell phones will check the weather on it at some point. Most of these phones, if not all of these phones, come with a weather app pre-installed when you get the phone. And that's because weather is pretty central to a lot of the decisions that we make in everyday life. So when we're considering what weather actually is, well, what it is it talks about how the atmosphere behaves at a given time, so at a specific time. So by that I mean that if I ask you for the weather, or if you ask me for the weather, chances are you're talking about the weather today, or the weather in the next couple of hours, or the weather this week, or the weather in the past few days, things like that. But you're not talking about weather in general in the area of the person that you're talking to. So for example, for me in Canada, if you ask me what the weather is, I'm not going to tell you, oh, Canada's cold. No, if you ask me what the weather is, I'll tell you what the weather is like today, where I am in my city on this day at this time, or in the next couple of hours, or how the next couple of days are looking. So it's a really specific time. So for example, if you were to ask me right now, what's the weather? I'll look outside my window, I'll tell you it's cloudy, it was raining all morning, it's still raining now, and it's supposed to rain for the rest of today. So that's the specific window of time that we're talking about right here. This at a given time business means that we're talking about a very specific period of time. And within that specific period of time, you can discuss all these things that show up right here. So you can discuss what the temperature is, what the precipitation is. Now remember that precipitation is rain and snow. So rain, there we go, you can have a little raindrop and a snowflake. Bam, there we go. I am not the most skilled at drawing these things with a cursor like this. But anyway, but that should give you the idea. But yeah, so precipitation is rain and snow, and for those of you that have experienced other types of weather patterns, or other types of precipitation like hail or sleet or things like that, um, then those all fall under precipitation as well. This is things that fall out of the sky during some sort of storm type event, and that encompasses precipitation. That's all precipitation. Other things that we can talk about when we're talking about weather, these things are less common. There's still things that you could find on your weather app or on a weather channel, but they're not as common if you ask somebody for the weather. So things like humidity, the direction and the speed of the wind, atmospheric pressure, visibility, cloudiness. These things don't come up quite as much when we're talking, when we're just having a conversation with our friends or family members or whatever. Um, Somebody asks what the weather is like. Basically, they're asking for the temperature and the precipitation. But the idea is that they're asking for the temperature and the precipitation at the present moment. So today, this week, last week, right around now, but not anything really more long term than a few days on either side of where you are right now. So these are some of the major things that make up what we mean when we say weather, although most people only really care about these ones up here, these two, and maybe depending on where you live, this third one right here, humidity, can be a reasonably important one as well. But yeah, so for the most part, those are the different things. And the important thing with all of those is that they can change very rapidly from one time to another, and they can vary pretty drastically from one place to another. So for example, if I'm talking to somebody who lives 3 hours away from me, um, then like a 3 hour drive away from me, then I might say that it's raining here, but over there it's not. It's clear and sunny and warm, and there's no snow on the ground, and it can look very, very different from how the weather tends to look over here, because a 3 hour drive isn't really that huge a distance. Like if you look at a map of anything, if you look at a map of Canada or you look at a map of the Dominican Republic, a 3 hour drive, sure, it takes a while and it does cover a reasonable chunk of distance, but on the scale of the whole planet, it's really not that much. If you look at the Dominican Republic on a globe, it's really not that big. So trying to cover 300 kilometers, a 3 hour drive would be something like that. If you're trying to cover about 300 kilometers, then it's really not that big a region that you're talking about before the weather changes from one place to another. So weather can change really rapidly from one time to another and from one place to another. So those are both important to discussions about weather, because this is where it differs from climate. So we're going to talk about climate in a sec, but before we get there, I wanted to just show you quickly an example of what I mean with how quickly weather can change. So if you look here, this is the weather in Pristina, Kosovo. So what we have here, I've just taken this screenshot right from Google. So basically what's going on here is, if you look at this right here, we've got the different times of day over the course of the next day. So they've set it up a little confusingly that this stuff down here is separate from these times right here. So this chunk up here is separate from the stuff below it. Oops, I just kind of cut through one of the times there. But anyway, so we have all these different times over the next 24 hours for how the weather will change in Pristina. So one obvious thing, and sort of the thing that most people care about, is how the temperature is going to change. So at 6 p.m. on Wednesday, you have that the temperature is 19 degrees Celsius, and it starts to drop going into the evening. It gets colder and colder until it hits 8 degrees in the early morning, so like early tomorrow morning, if you will. Of course, that depends on when you're watching this. and then the temperature will rise during the morning up until it hits about 22 in the mid-afternoon tomorrow, so around 3 or 4 p.m. Tomorrow. Uh, and so you can see that the temperature varies quite drastically. Like here is there's a 14-degree difference between the 8 degrees down here and the 22 degrees up there. So it's a pretty reasonable difference in not that much time, just a matter of a few hours, it'll get significantly warmer. And then if you look down here, that's how it's going to change how the temperature and also the precipitation, as you can see in the pictures, is going to change over the next several days. So you can see that they're looking at a pretty warm week, 23 degrees, 26 degrees, 25 degrees, 26 degrees. So they're going to have some nice weather over the next few days, but the cloud cover will change. They'll go from having mostly sunny daylight hours on Wednesday to all cloudy on Saturday and then rain by Monday. Now, of course, that's not a super quick change in weather patterns. Uh, like on a human timescale, a couple of days isn't a very quick change for something like that. But on the scale of the kinds of processes that happen on the Earth, that happen on the orders of years, decades, centuries, millennia, anything that changes in a couple of days is a really quick change. So that's one of the keys to weather. Now, before we get into a discussion on climate, I'll also show you these two other tabs, this precipitation and wind tabs, just so you can see how the precipitation and wind are also expected to change over the next 24 hours. So here's another example. This is the precipitation tab. We can see that the chances of precipitation don't change a ton over the next several hours, but they do change a little bit. This just happens to be, I guess, a day where there's not very much rain expected in Pristina, so it's not necessarily the best example of this. But I'm sure you guys have experienced yourselves many times before where the morning is sunny and clear, and then it's pouring rain by lunch, and then it's sunny and clear by 3 in the afternoon again. And that's reflected in your weather app where it'll say, low chance of precipitation here, and then a really high chance here, and then a low chance over here. Things like that. So those things, I'm sure you guys have seen those before. And one last thing we'll look at is wind. It's not something that we tend to discuss very much, but we'll have a look at it anyway. So here you can see, just quickly, how the wind changes from time to time within Pristina. Now, of course, it can change on such a small scale, like distance-wise, that this data would all have to be taken at some specific weather station where they obtain these numbers and these directions for how right now you can see that the wind is, I presume it's supposed to be indicating north and a little bit to the east over here, but then it'll be further westwards, like the wind will be moving towards the west at 4 a.m., but then it'll be moving towards the east at 4 p.m. So it changes direction and it changes speed from 13 kilometers per hour down to 5 in the middle of the night, and then up to 19 tomorrow afternoon. So these kinds of things can change, and they could probably change within the city of Pristina itself. So this data is specific to wherever they actually obtained these numbers, and it's not necessarily going to apply to everywhere in Pristina itself. So basically what we've seen so far with weather is that there are lots and lots of different things that make up what we call weather. And the main idea is that they can all change on a really short time scale and across really short distances. So with climate, the difference is it's not different in the kinds of things that it's discussing. It's still talking about temperature, it's still talking about precipitation, all that good stuff. But instead of talking about how that weather occurs or changes over a short period of time, now we're talking about how weather behaves, how the atmosphere behaves over a longer period of time, on the order of a few decades, 30 years or sometimes more. I guess more if you have more data for it, but like a few decades is not unreasonable for estimates for climate. So basically, all these words that we've seen before, temperature, precipitation, humidity, wind speed, and wind direction, those all uh, those are all words that we saw when we were discussing weather. And so now when we switch from weather to climate, that's what these arrows are indicating. So basically we've gone from weather on the left to climate on the right. And so then we get all of these words right here. So we've got average temperature. Instead of just temperature, now we've got average temperature. Instead of precipitation, which we saw before, now we've got average precipitation. And the same for the rest of these. Humidity, wind speed, wind direction, they all become average humidity, average wind speed, average wind direction. And so what you can do then is you can look at the weather over the past 30 years, and you can make some predictions about what you would expect the weather to look like in a given area at a given time of the year. So obviously it's not the most useful thing if you give a yearly average temperature, because like for example in my city, in the summer we can hit temperatures that are like maybe plus 32 degrees Celsius, and in the middle of summer and in the middle of winter we'll hit temperatures of minus 32 degrees Celsius. So that's a huge change in temperature. So if you go through and you do an average, now of course it's not going to be minus 32 degrees for the same period of time as it's plus 32 degrees, but so if you do the average, you might not come out to exactly 0 degrees Celsius. You might get like 5 or minus 5 or 3 or minus 3 or something like that. And that's not the most useful, because that's taking into account weather that's, the middle of the day in July and combining it with the weather from the middle of the night in January and saying, yep, here's the average temperature in this area. And that's not the most useful, because if I want to know, we're at the end of April here, if I want to know what's the weather usually like towards the end of April, I don't want to hear about the average of December middle of the night and June middle of the afternoon. So it's more useful when we're talking about average temperature and average precipitation. Usually we'll talk on a more meaningful timescale. So maybe the average temperature and precipitation in a given month, or the average temperature of a given day in history. We have enough climate data that you could look back at, okay, on this day in the last 30 years, there's been an average temperature of this. And so then you can expect those kinds of temperatures to occur more or less the same way year after year around that date. Now, of course, it's going to change from one year to the next, but generally not by too much. So if the average temperature for today in this part of the country is 14 degrees Celsius, then it might not be 14 exactly. Maybe it'll be 18, maybe it'll be 10, maybe it'll be 20, maybe it'll be 5, but chances are it's not going to be like minus 15 degrees or plus 30 degrees. I have some idea of if it's usually around 14 degrees, I should probably be within a few degrees warmer or colder compared to that for this time of the month, in this time of the year. So those are the kinds of ways in which we can use these values to get a better understanding of what the weather patterns are typically like at this time of year in this type of place. And so let's move on to the next slide here, which highlights this difference. So yeah, so basically, long story short, weather is discussing things in the short term. So it talks about temperature, it talks about precipitation, cloud cover, wind speed, wind direction, humidity, all that good stuff, visibility. And climate takes into account a lot of the same things, but is discussing them on a more long-term basis. So it kind of answers the question of what's the normal weather in this area at this time of year. So if you were to take any city and you wanted to know you're going to travel there in 2 months, you want to know, it's the end of April right now when I'm recording this, so let's say you want to travel to Berlin, Germany, and you want to know what's the normal weather in Berlin at the end of June? The end of June being 2 months away from now, it's too far away that if you go on a weather app, you're not going to see a prediction that's more than 2 or maybe 3 weeks ahead of where you are right now. So if we're at the end of April, end of June is too far for you to find a reliable prediction for those things. So what you do is, instead of looking for weather forecasts, you look at climate data and you look at, okay, well, the temperature in Berlin is usually this in June, or maybe usually this in June and in July. If you're traveling at the end of June and you're going to be staying into July, then maybe you look at the data for June and July, and then you plan accordingly. What clothes are you going to pack? Where are you going to go? What kinds of things are you going to do? Because those things will change depending on if it's plus 30 outside or -5 and snowing, right? So climate is good for that long-term, for taking that data over a long period of time and then using it in a meaningful way. So it helps for regular civilian purposes. It allows us to understand what normal weather is at a given time of the year for a given place. Now, of course, it has its scientific advantages too. This map right here shows the temperature difference um, over the course of a few decades. And so the redder the region of the map is, so like over here, the more the temperature, the more the average temperature tends to increase. And so this is one of many, many maps that you could find pointing at indications of climate change, where many regions of the world are just getting warmer uh, year after year. And you can spend some time and look up these kinds of these kinds of climate change maps or climate change data, and you can see how the average temperature over different areas is starting to increase. So the fact that we use average temperature and average precipitation and things like that in our climate data allows us to generate things called climate graphs. So these allow us to take the average temperature in a given area, and we take the average precipitation in that same area, and we plot them on the same graph. So we've got this graph here. The red line indicates the temperature, and the blue bars indicate the precipitation. And the way that they split up this graph is, you can see at the bottom here, it runs from 0, 1 over here to 12 over there, over on that right corner. So these represent the 12 months of the year. So the first one being January, going all the way to December in the other corner. And so basically what this shows is how the temperature and precipitation change for each month of the year in the area that you're looking at. So you'll find some information that's, some additional information, like things like altitude above sea level and things like that. But basically what we're interested in is these graphs here, and this is the stuff that you've been working with in your climate projects. So basically, from this graph, you can see, just by looking at the blue bars means rain and snow, or in the case of Santo Domingo, just rain. You can see that it tends to rain a lot more in these summer months, right? But it rains considerably less in these winter months, which is useful to know if somebody, if you're about to plan vacation to Santo Domingo, then it's useful to know when does it tend to rain more, or how does the temperature change. You can look at the red line for that the temperature in Santo Domingo is fairly constant over the course of the year. It changes a little bit. It's like 24 degrees over here in January, and then it's up to maybe 27 degrees or so here in July and August. So it changes a little bit, but nothing too drastic. But this graph, what it does is it takes that temperature and precipitation data, and it gives you this visual representation, this thing that you can just look at and understand that this is when it's hot, this is when it's not as hot, this is when it rains a lot, snows a lot, whatever. And so this is something that can be really useful to understand the climate of a particular area. So we talked about this in the last lesson, and you guys have the slides and things like that for this lesson. So we're not going to cover it in too much detail, but just as a reminder, you can look at the climate graph, and by considering each of these 3 points, you can determine whether that city that you're looking at the data for has a continental climate or a maritime climate. So if you look at the temperature range, so how much that red line moves up and down over the course of the year. So what I mean is, if you've got a climate graph, if you've got your climate graph, this is 2 separate ones, then you might have a temperature range that's just a little bit over the course of the year, or you might have something that changes very drastically over the course of the year. So that's this first point, this change in temperature range. The second one is precipitation. So that's the height of the blue bars. You might have a region that has really tall blue precipitation bars. My apologies for my poor drawing skills. So you might have a region that has these really tall bars for precipitation, and then you might have other regions where it really doesn't rain or snow very much at all. And so that helps you as well in this point here in determining whether a climate is continental or maritime. And then the last one is when does most of that precipitation occur? Is it mostly in the summer or is it mostly in the winter? So you could have these tall blue bars here, but then in November and December it really doesn't rain that much at all. But it rains a ton in June, July, August, for example. Meanwhile, over here, you might have that it doesn't rain that much over the course of the year, but it is still more in January and December and November, and then not very much at all in like May, June, July, August kind of months. So that's for this point right here. And so putting all 3 of those together, if you find that a certain area has, let's say it's got a large temperature range, that means it's got this continental quality to it. But let's say it has a lot of precipitation, so more than 1,000 millimeters. That's a maritime quality. And let's say that most of that precipitation occurs in the winter, which is also a maritime quality. That's where this stuff down here comes into play, where if you've got some continental, some maritime qualities, basically whichever one it has more of, more continental or more maritime qualities, then that tells you whether that region has a continental climate or a maritime climate. If you need a refresher on this, check out the previous lesson where this is discussed kind of by itself, because the previous lesson was just a primer for the climate project itself. And if you're still stuck, send me an email and we can talk about this further. So just to show you an example of how these climate graphs can change for different areas, Uzbekistan is a country in Central Asia, which is pretty far away from any reasonably sized body of water. And so it's not unreasonable to expect that it has a continental climate. And if you look at the climate graph here, you can see that there's this huge range of temperatures where it's got an average temperature of about 0 degrees in January, but it's got an average temperature of about 28 degrees right here in July. So it's got this huge temperature range. Now the blue bars, you have to be careful when you're looking at this for your climate project. The blue bars appear to be taller, some of them, like this one right here, appears to be taller in Tashkent, Uzbekistan, compared to all the blue bars over here in this maritime climate. But you need to be careful and look at the scale on the axes. So it might be a little difficult to read depending on the size of your screen that you're watching this on. But you have to be careful and look at the numbers on the scale for the precipitation right here. Because if you look at the Uzbekistan side, then this highest number for precipitation in millimeters is 105. But if you look over here on the Panama side, the highest number for precipitation in millimeters is 385, which means that technically this blue bar right here, that's at about 105 millimeters on this Uzbekistan graph, would actually only be about this high Maybe if I do that in black so you can see it a little bit better. It would only be about this high on the Panama graph. And so you can see I've taken, this was month number 4, this is April, so I've put it right over top of the April one here. So even this tallest bar on the Uzbekistan side isn't even as tall as the April bar for that same month in this Panama climate graph. So you can see that you have to be careful with looking at the height of those bars and determining how much it rains. What these bars do tell you is when it rains more. So sure, maybe it's only 105 millimeters of rain in April in Tashkent, Uzbekistan, but it's more so most of that rain falls in these winter months from November, December, and then January, February, March, April up to May, and then there's hardly any rain between June, July, August, and September, and October, I guess, as well. So you can see that even though these values on the axis might change from one graph to the next, they do still do a good job of showing you, if I get rid of all these lines, they still do a good job of showing you, how that precipitation changes over the course of the year. So I could almost draw it out like this, and you can see then that most of the precipitation occurs in the winter months. Meanwhile, if we look at this second one over here, this maritime climate in Cologne, then what we get is that the temperature is very, very consistent. You can see that it's almost the same pretty much all year. It's basically 25, 26 degrees Celsius all year in this particular city. But we can also see that it rains a lot more because these numbers go a lot higher, and a lot of these bars are very, very tall. A lot of these blue bars are very, very tall in comparison to the ones over here. So we can see that it rains a lot more, and if you added these up, you'd get that it's probably quite easily over 1,000 millimeters, if not more like 2,000 millimeters of rain over the course of the year. And we can also see that most of that precipitation seems to occur, you could say, in the summer months, because there's not so much in January, February, March, April, and then it really picks up May, June, July, August, September, October into November, and then it dips down again. December, January, not so much. So using these graphs, you get this information of how much the temperature changes, how much precipitation there is, and how that precipitation changes from one month to the next over the course of the year. And so that can give you a pretty good idea of what the climate in that region is like. So what you can do, for those of you in the class, you guys have hopefully already done it, but for anybody else that happens to be watching this video, look up your own city's climate data. You can do that on climatedata.org, so climate data with a hyphen in between, climate-data.org. Type in your own city, and you can check the climate data there and see if it kind of lines up with what you know about the common weather patterns in your city and how they change over the course of the year and from one year to the next. Now, climates of different regions can change relative to one another. So, or like you'll find that different regions have different climates, and that's not unreasonable. Some parts of the world are known to experience warmer weather for long periods of the year, or a lot of rainfall, like monsoon season in India would be a good example of that. Areas that commonly get hit by hurricanes as well might have much higher rainfall than other parts of the world. Alternatively, we've got areas of the world that tend to get very, very cold, so that could be considered northern Canada, northern Russia, Antarctica, Finland, Norway, those kinds of places, Iceland, or very dry. And so that could also be the same places as those very cold ones, or it could be very hot places that just don't get any precipitation. So that could be like the Sahara Desert would be an example of a place that's hot but also dry. And so we have this understanding of different regions experiencing different climates. And so in some cases that can be due to how close the region is to a body of water. So that's what this fourth point here says. These variations can be due to things like the proximity, which means closeness, to a body of water. So if you rewind a couple of minutes, unfortunately I can't go back slides when I'm recording on PowerPoint this way. If you look back at the previous slide and you look up where Colón is in Central America, you'll see that the whole of Panama is very, very close to large bodies of water. It's a tiny sliver of land separating the Atlantic and the Pacific Oceans. And so you can understand from this fact that climate can be influenced by how close the region is to a large body of water. You can understand that the climate in Panama, through all of Panama, is going to be pretty significantly affected by it. Whereas for the Uzbekistan case, I deliberately picked a region that's very far away from large bodies of water, and so it experiences a very continental climate. And so in those ways, you can see that there are these differences based on, are you close to water, are you far away from water, things like that. But there are also seasonal differences, and not every part of the planet experiences seasons in the same way. So for example, you'll have areas near the tropics, which we'll discuss in the next lesson, which don't really experience winter and summer, like cold and hot. They experience more of a rainy season and a dry season. And sure, maybe the temperature changes a little bit, but really not that much. It's mostly that the humidity changes and the amount of precipitation changes, but most other things don't. Whereas in different parts of the world, you'll have warm summers, cold winters, or mild summers and kind of cool winters, or very, very long hours of daylight in the summer and very, very little daylight in the winter. And so these things change depending on where you are on the planet and what time of year it is. And so these are things that we'll discuss in our next lesson when we discuss seasonal differences. So it was something I initially planned to incorporate into this lesson, but if you just look at this diagram right here, there's kind of several things going on here, and there's more to this diagram that's not really included in what you can see here. So we will reserve a discussion on these seasonal differences for another time. So basically the focus of our next lesson will be seasons themselves. Why do we have seasons? And how do they manifest themselves in different parts of the world? And we can use this to get a better understanding of how different climates appear in different parts of the world based on these seasonal differences. So that's where we're going to leave off for today. We will discuss seasons in our next lesson. If you have any questions, let me know through Google Classroom, email, Insta, whatever's convenient for you. But yeah, if I don't hear from you, then have a good one.